Hi everyone. So last video we saw how to find the Eigen value for this sum, and now we will find the Eigen vector. Okay. So the Eigen values are 2, 2, 8. If all the Eigen values are different, the problem will be super cool and it will be very easy. If we have two same Eigen value, there will be a little bit twist. So we can easily eliminate that twist. Okay. So first we have to find the eigenvector in this problem. So what we'll do, we'll take the different eigenvalue, that is 8, which is not the same as 2 2. So we'll take 8. So before starting this, you have to just make a standard format, that is how to find the eigenvector. The formula for the eigenvector is nothing but A, which is the given matrix A, minus lambda I, and it will be into x bar, that is equal to 0. This lambda is nothing but the eigenvector and I is nothing but the unit matrix. See, if we are using 3 cross 3, so the unit matrix will be 3 cross 3. The leading diagonal will be 1, 1, 1. Remaining everything will be 0. That is known as unit matrix. So what is A? A we know, that is 6 minus 2, 2 minus 2, 3 minus 1, 2 minus 1, 3. Okay. And minus, this is lambda, and we have I. So what happens, for the I is unit matrix for 3 cross 3, so leading diagonal will be 1, remaining all element will be 0, and we have lambda outside, so this is lambda, and this x bar can be written as small x1, x2, x3, that will be equal to 0. Okay, so when we multiply this lambda inside, this will become minus, the leading diagonal will become lambda, lambda, lambda. Okay, so we have A matrix minus lambda, 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 remaining all will be 0. Then what we have to do, we have to subtract this from this. So what will be the final answer for this? That is 6 minus lambda. Okay, so write in the diagonal first 6 minus lambda, and the second one will be 3 minus lambda, that is 3 minus lambda, and the third one will be 3 minus lambda, and remaining minus 2 minus 0, everything is 0. So any number minus 0 will be the same number, so we can write as it is. So here it will be minus 2, here it will be minus 2, here it will be 2, here it will be 2, here minus 1, here minus 1. This is a matrix, and this side we have x1, x2, and x3. So what you do, just make a general form like this, then you can substitute each lambda. For example, we have lambda 8 and 2. So what we will do, we will first substitute the lambda is equal to 8. So what we will do, we will just substitute case 1, substitute lambda is equal to 8. So what happens if we substitute 8 in this equation? So just write the, so 6 minus 8 will be minus 2, 3 minus 8 will be minus 5, 3 minus 8 will be minus minus 5. And other things are will be same, minus 2, minus 2, 2, 2, minus 1, minus 1, and we have x1, x2, and x3. That will be equal to 0. So in this case, we have three equations. So what is the first equation? That is minus 2 x1 minus 2 x2 minus 2 x3. So that will be the first equation. So what is the first equation? Minus 2 x1 minus 2 x2 plus 2 x3, that is equal to 0. And the next one is minus 2 x1 minus 5 x2 minus 1 x3. So minus 2 x1 minus 5 x2 minus 1 x3, that is equal to 0. So we can write similarly the third equation, that is 2x1 minus 1 x2 minus 5 x3 is equal to 0. Okay, so from this we have to find the eigenvector. So what we have to do, we have to take two equations, that is we will take the first two equation, we'll take equation 1 and equation 2. So how to find this is, we have to write x1 x2 x3 as x1 x2 x3, and make sure first you will write this coefficient, the second coefficient, that is minus 2 for the first equation, minus 5 for the second equation. Then we'll go for this, that is 2 minus 1. So 2 minus 1. Then we have to write this one, that is minus 2 minus 2. Again we have to end where we started, so that is minus 2 minus 5. So we have to write minus 2 minus 5. Okay. So next we have to find what is x1 and x2 and x3. So how we can find this? We can write x1 by, we have to cross multiply this. So minus into minus will become plus, that is 2 minus of 5 2s are 10. So minus 10. Okay, and the next one we can write it as x2 by minus 2 into minus 2 will be minus 4, minus of minus into minus will become plus, that is 2. And the third we can write it as x3 by minus 2 into minus 5, that will become plus 10, and minus of 2 2s are 4. So this one will be x1 by 12, x2 by minus 6, x3 by 6. So we can write it as x1 by 12, x2 by minus 6, and x3 by 6. So we can easily say that we can, this all the three numbers are multiple of 6, so we can divide this by 6. So what we will get, that is x1 by 2, x2 by minus 1, x3 by 1. So what is the eigenvector? So eigenvector, that is x will be 2 minus 1 1. So this is the one of the eigenvector. Okay, so after finding the eigenvectors also, if we want, we can do the check. Okay, that is 2 minus 1 1. So just take the any one of the equation. We solve this two equation, just take the third equations. So 2x1 minus x2 minus 5x3, that is, we can do a check if we need, that is 2x1 minus x2 minus 5x3 minus x2 minus 5 x3, the equation should be equal to 0. So we know what is our x1. X1 is 2. So 2, 2, and this is minus 1, and this is x raised 1. So 2 2s are 4, plus 1 5, minus 5, that is equal to 0. So this will be 5 minus 5 is equal to 0. So ultimately 0 will be equal to 0. LHS is equal to RHS. So ultimately we can know that our eigenvalues, right? Okay, so this is how you find the eigenvalues and you check the eigenvalues. Okay, so that's all in this video. Next video we will try to find out the another eigenvector for 2.